Who knows what heat capacity is? The definition of heat capacity. Yes. Yes. He said how much energy it takes to change the temperature. It's a little bit more detailed than that, but I like it. It's how much heat I need to raise some amount of mass of something by 1 degree. So when heat is added to a substance, we expect its temperature to rise, okay? Unless the heat flowing in is going to something else, right? So that could be mechanical work, a phase change, which we won't cover in this class, or breaking bonds, and of course, our discussion of disruption of bonds. We've talked about it a little, we'll talk about it even more. Okay? So let's assume that all of the heat flowing in is going to raising the temperature. How much that temperature goes up depends on a couple things. How much heat I put in, how big is Q? The substance itself, okay, how much it wants to heat up, what it is. Conditions under which heat's applied, so other things going on in my system and surroundings. So here's what's the notation for heat capacity? It's the letter capital C. Okay, or at least this is what we'll use in this class, okay? Heat capacity, the amount of heat required to increase the temperature of a certain amount of substance by 1 degree Kelvin, okay? This definition might be ever so slightly different from what you've seen in other classes. Learn what we do here, okay? What are the units of heat capacity? Or the SI units? I don't want mole on the bottom yet. I do want joules, and the bottom is the degree Kelvin. Energy per temp, joules per Kelvin is not on the slide. Does that appear anywhere? Joules per Kelvin is what I want. Okay. So heat capacity is change in heat with respect to the change in temperature. So how much heat do I put in? How much temperature increase do I get? Heat is joules, temp is Kelvin. Yes, I thought that appeared somewhere. Guess not. So there's the definition again. Is this an extensive or intensive property? Is heat capacity extensive or intensive? Is joules extensive or intensive? Energy depends on how big the system is. Okay? Temperature doesn't. Does matter divided by doesn't matter means it does. This is extensive, right? And that's kind of baked into the description here. A certain amount of substance, the amount I have makes a difference, okay? Heat capacity is an extensive property with units, joules per Kelvin. Specific heat. This is different. Specific heat is heat capacity per unit mass. And this is where moles or grams or something comes in, okay? Our book doesn't, I don't even think it defines specific heat ever, and it never uses it anywhere, okay? So this is a scenario where we will always use heat capacity, and I will tell you how many moles we're talking about, whatever our unit amount is. Hopefully that'll be easy. Okay. The value of heat capacity for us, it's a way to connect heat flow to temperature change. Remember that these two things are not necessarily connected. Heat flowing in doesn't mean you have to have a temperature increase and vice versa. We just talked about that. Okay. Temperature is not a direct measure of heat. It's the average kinetic energy of the particles in the substance. And it's possible through adiabatic or isothermal expansion to have these differences. This YouTube video is on the difference between specific heat and heat capacity. Okay? Those two differences. Specific heat is intensive. I got moles or grams on the bottom. So I have extensive over extensive, it becomes intensive.